To begin, open Packet Tracer. We will now create a topology with 3 routers, 3 switches and 3 PCs and implement IPv6 on all devices and then configure static and default routes amongst the routers. To begin, we're going to add 3 2811 routers. We've got to use the 2811s because they do support IPv6. And we will name them R1, R2, and R3. We will add a switch to each router. And we will name them S1, S2, S3. Finally, we will add PCs to each router. And we will name them PC 1, 2, 3. So this will be PC 3. This will be PC 2. This will be PC 1. We will now add the wide area network card interfaces to the routers. So we go to the physical, turn the router off, then add a single WIC1 tree to this router and boot him back up. We do the same thing here. Shut him down. Add a single WIC1 T to this router and bring him back up. And on this router we will have to add 2 of them, since it connects to routers 1 and router 3. So we will insert 2 wide area network cards into this router, then bring him back up. We will now create the connections between the devices. To begin with, we will make the Ethernet connections from the routers, first Ethernet port, to the switches, first Ethernet port, then from the PC Ethernet port to the switches, second Ethernet port. We repeat this. Then we will make the wide area connections. We will provide clocking on routers 1 and router 3. When we hover over the connections, we see that the timing device is on the interface of router 1 and router 3. We will now assign the IPv6 addresses to the computers. assign the IPv6 address for the router as the gateway. We will verify this configuration with the IPv6 config command. We repeat these steps on PC2. And again, we will verify this with the IPv6 command. And again, we will verify this with the IPv6 config command. Next, we will assign IPv6 addresses to the routers, interfaces, and then open them up. We begin with router 1, go to the CLI, enable config t, then we give him his name, R1. We will disable DNS in case we mistype a command we do not wish to be held ransom. Next, we go into the interface F0/0 and assign it an IPv6. But before we can do this, we have to actually enable IPv6 on the router. So the command is IPv6 unicast-routing. Then we can assign IPv6 addresses to the interface. And we open the interface up. We're going to do the same now on router 2. And finally, on router 3, we will now test connectivity from the PCs to the routers by pinging them. So we go to PC1 and ping its gateway, which of course is the router. And we have communication. I'll do the same on router 2. And we have communication between the router and the PC. One more time. All is well at this point with regard to the Ethernet connections. Next we will configure IPv6 addresses to the wide area connections. We hover over this connection to see how they are connected. And we see on router 1 it's S0/2/0 connected to router 2's S0/2/0. So we're going to pick that interface. We're going to assign an IPv6 address to it. We assign timing to it, and we open it up. Now we're going to repeat these steps on router 2. And we will try to ping router 1 from router 2 on its serial interface. And we have communication. We'll do the same on router 1. And we have good communication. Do the same for the connection between router 2 and router 3. So we will hover over this connection to see how they are connected, and it's S0/2/0 on router 3 to S0/0/0 on router 2. So here we go. Again, we will place the timing on this router, open the interface up, and now we will connect the corresponding interface on router 2. And open it up. We will now ping router 3. There we go. And we will now do the same from router 3. we have communications between routers 2 and 3. We will now configure the RIP next generation routing protocol on those 3 routers. And we have to go to each interface and enable the RIP next generation protocol there. Use the up arrow key, and that takes care of router number 1. We will now go to router number 2, do the same thing there. And again use the up arrow key. And one more time on router number 3. As you see, to enable RIP is fairly easy. Again, we can just use the up arrow key and make this a permanent configuration on each of the routers. The copy run start command. And now let's see if we have IPv6 RIP next generation routes advertised. Yes, there we are. 1 to the network attached to router 2, 1 attached to the network attached to router number 3, and 1 to the network that connects routers 2 and 3. We'll do the same thing here. And here we have 2 RIP routes, 1 to the network attached to router 1 and 1 to the network attached to router 3. And here we have 3 again, 1 to the network attached to router 1, 1 to the network attached to router 2, and 1 to the connection between routers 1 and 2. So let's ping across again. Let's ping PC1 and PC3. There we are. Let's ping the other way around. And lastly, let's ping PC number 2. And as you see, we have a sound routing configuration with the RIP next generation protocol.